All right, so today we are going to talk about force at an angle. We do it exactly the same as we've done all the questions up until this point. The only difference is that any force at an angle needs to be broken into its horizontal and vertical components. You're going to notice that any force at an angle, you can draw a right triangle to represent the vertical and horizontal components of that vector. So we're going to use the primary trig ratios of sine and cos to find the values of the horizontal and vertical components of the applied force. Just a quick reminder, sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is opposite over adjacent. If this were my angle of interest, the hypotenuse would be the longest side, the one across from my angle is the opposite, and the one beside it is the adjacent. Let's look at an example of a force at an angle and see if we can break it into its vertical and horizontal components. So here we have an applied force that is pulling up and to the right, and we're going to break that into the vertical and horizontal components that make it up. And we're going to use the primary trig ratio of sine of the angle, which is opposite over hypotenuse, and cos of our angle, which is adjacent over the hypotenuse, because we have the hypotenuse and we're looking for both the opposite and the adjacent. So sine of 35 degrees is equal to the opposite, which is Fy, over the hypotenuse, which is 154. And so Fy is equal to 154 times sine 35. We're going to do the same thing over here. We have cos of our angle of 35 degrees is equal to our adjacent, which in this case is Fx, over our hypotenuse, which is 154. And so Fx is going to be that 154 times cos 35. We're going to use our calculator to find those values. Make sure your calculator is in degrees, especially if you're in pre-cal right now. Make sure that your calculator is not in radians, but that it is in degrees. So we have 154 times sine 35, and that gives us 88.3 newtons for the vertical component, and 154 times the cos of 35, which gives us 126.1 newtons for the horizontal component. Once we've broken our applied force into the components that make it up, the vertical and horizontal parts, we no longer use that applied force. You will not find the applied force anywhere in your analysis because it doesn't belong in the vertical category and it doesn't belong in the horizontal category. It is at an angle. That's why we've broken it into the vertical and horizontal components. The Fy and the Fx will be replacing the Fp. We will not, I repeat, we will never have an applied force that's at an angle in our vertical or our horizontal components. We will break it up into the parts that make it up and then include it in the category where it needs to be. So let's take a look at a full problem. We're going to read the problem, we're going to write down the important information, and then we're going to draw a free body diagram that represents the forces acting in this situation. So we have a mass of a crate of 45 kilograms. We have a coefficient of friction of 0.2. We're going to put 0.20. We're going to change that to 2 sig figs. Oops. We're going to change that to 2 sig figs. We have a rope that's attached to a crate, and we're applying a force of 115 newtons to that rope at an angle of 15 degrees above the horizontal. They want to know how much time passed between the time the crate just started till it gets up to a speed of 1.4 meters per second. So we're going to use dynamics to find the acceleration so we have enough information to find the time. So the situation is very similar to what we've seen before. We have gravity pulling us down. We have normal force opposing gravity. We have frictional force opposing our motion, and this time the applied force is at an angle. We're going to take that applied force and we're going to break it into the components that make it up. We use Fx to represent our horizontal component, and we use Fy to represent our vertical component. So we have sine of our angle, which in this case is 15 degrees, is equal to the opposite, which is Fy, over the hypotenuse, which is 115. So Fy is equal to 115 times sine 15. And we get an Fy of 29.8 newtons. We're going to do the same thing horizontally. To find the horizontal component, we're going to use cos, and it's equal to the adjacent, which is Fx, over the hypotenuse, which is 115. And so Fx is equal to 115 times the cos of 15. And so we get that Fx is equal to 111.1 newtons. Now that we've broken the applied force up into its vertical and horizontal components, you will not be using the applied force again. The applied force, Fp, will not be found in your vertical and horizontal analysis. It's really important. Vertically, we have the normal force, which is positive, and we don't know what it is. We have the gravitational force, which is negative, and it's found using mg. We know that the mass of the crate is 45 times the acceleration due to gravity, which is 9.8. So we have a gravitational force of 441 newtons. Now there's a new force here in the vertical component, and it's Fy. Notice that Fp is pointing to the right and up. Since it's pointing up, that means Fy is going to be positive. Our Fy is 29.8 newtons. Now we're going to do our Fnet equals ma. Vertically, our crate is not moving, so we're going to say that we have an acceleration of 0. And Fnet is made up of these three forces. So we have the normal force minus the gravitational force plus Fy equals 0. So Fn is equal to Fg minus Fy when we bring it to the other side of the equation. And so Fn is equal to 441 minus 29.8. So we have that Fn is equal to 411.2 newtons. Now we're going to analyze horizontally. Horizontally, we have Fx, which is positive, and it's equal to 111.1 newtons. We have Ff, which is negative, and it's equal to mu Fn. Our mu is 0.20 times our Fn, which is 411.2. And so we get a frictional force of 82.24 newtons. These are the only horizontal forces acting on our crate. Notice Fp is not included because Fp is not horizontal. Now we're going to do our Fnet equals ma. Fnet is made up of Fx minus Ff equals ma. We're going to fill it in. Our Fx is 111.1 minus our frictional force of 82.24, and that equals the mass of the crate times the acceleration. So when we do that subtraction, we get 28.86 equals 45A, and we're going to divide by 45 on both sides. And so we get that A is equal to a 0.64 meters per second squared. The question, however, didn't ask for acceleration, it asked for time. So we have an acceleration of 0.64 meters per second squared. We have an initial velocity of 0. We have a final velocity of 1.4 meters per second, and they're asking us for time. So acceleration is final velocity minus initial velocity divided by time. So 0.64 is equal to 1.4 minus 0 divided by time. So time is equal to 1.4 divided by 0.64. And so the time is going to be 2.2 seconds. So it takes 2.2 seconds to reach a velocity of 1.4 seconds. At this point, I would like you to pause the video and try the check your understanding question. Once you've completed the check your understanding question, I'll ask that you unpause the video and come back and check and make sure that you're doing your calculations correctly. All right, so let's take a look at the check your understanding question together. We have to be careful this time because the grocery cart is pushed. Since it's pushed, that means our applied force is downwards. So let's write down what we know. We are applying a force of 450 newtons. This is at an angle of 30 degrees down from the horizontal. And we know the mass of the shopping cart is 42 kilograms, and we have a coefficient of friction of 0.60. They're asking us to find the force of friction and to find the acceleration. So we're going to draw a free body diagram to represent the situation. We have normal force pulling us down. We have, we have gravitational force pulling us down. We have normal force opposing the gravitational force. And we have force of friction opposing our motion. This time we're pushing. So our applied force is down and to the right, and we're breaking it into the horizontal and vertical components that make it up. This angle is 30 degrees, and we're looking for our Fx and our Fy. So we have sine of 30 degrees is equal to our opposite over our hypotenuse. And so Fy is equal to 450 times sine 30. So our Fy is 225 newtons. We're going to do the same thing to find our horizontal component. The cos of our 30 degrees is equal to our adjacent, which is Fx, over our hypotenuse, which is 450. And so Fx is equal to 450 times cos 30, which is 389.71 newtons. Now that we have our force broken up into its vertical and horizontal components, we're going to analyze vertically and horizontally. Vertically, we have the normal force, which is positive, and we don't know what it is. We have the gravitational force, which is negative, and it's equal to mg. The mass is 42 times 9.8. So 411.6 newtons. We have the vertical component of our applied force, which we have to be careful. It's pointing downwards, so it's negative. The Fy is going to be a negative 225 newtons. And so F net equals MA, where A is 0. So Fn minus Fg minus Fy equals 0, which means that Fn is equal to Fg plus Fy. So Fn is equal to 411.6 plus 225. And so we have a normal force of 636.6 newtons. Now we're going to analyze horizontally. Horizontally, what forces do we have acting? We have Fx, which is to the right, and so it's positive, and it's 389.71 newtons. We have Ff, which is negative, and it's equal to mu Fn. Our mu is 0.60. We calculated our Fn to be 636.6. So we have a frictional force of 381.96 newtons. We have that F net is equal to MA. F net is made up of Fx minus Ff, and it's equal to mass times acceleration. So we have 389.71 minus 381.96 equals our mass of 42 times the acceleration. So we're going to do that subtraction. We have that 7.75 equals 42a, and so we're going to divide by 42, and we get an acceleration of 0.18 meters per second squared. So the question asked us to calculate the force of friction, which we did. It's going to be 2 sig figs, so 380 newtons for our force of friction. And it asks us to determine the acceleration of the cart. And so the acceleration of the cart is here at 0.18 meters per second squared. I have already distributed the worksheet for force at an angle as well as the solutions. You will have the class on Monday to work on these questions. You have enough information now that you should be able to complete the last question on the assignment.